Hi, my name is Scott Moore with Moore Engineering. I'm here today to talk to you about sensor preparation for use with the BOT-3000E tribometer. As previously viewed in my other video, you should already be familiar with the basic operation of the BOT. If you haven't already watched this video, I recommend that you watch it prior to watching this one. This video will be about how to use all the tools here in order to prepare and maintain the sensors used with the BOT-3000E tribometer. We're going to focus here on sensor preparation specifically related to the ANSI A326.3 standard test method. This is the SBR sensor used with the BOT for dynamic coefficient of friction testing per the ANSI A326.3 standard. The rubber on the sensor should be 4 plus or minus 0.2 millimeters in thickness when new and should not be used when the thickness becomes less than 2.5 millimeters. The next tool is the sandpaper. This is a 400 grit waterproof sandpaper that has been cut to fit onto the reconditioning tool. The next object here is the reconditioning tool. To use the tool, you hold the handle in one hand and take the rotator out of the tool with the other hand. The final tool here is a paintbrush. This will be used to brush the particles from the sensor and the sandpaper itself. There are a series of paintbrushes here, the simplest of which is a basic chip brush. This will work fine. However, using a standard 1-inch wide paintbrush that has been cut about 1 inch in length works best, as it is a little stiffer and holds up much longer. The goal when performing sensor reconditioning is to ensure that the bottom of the sensor does not have any wear patterns or flat spots, such as in the case of this sensor, which you can see has a pretty significant wear pattern on the bottom where the sensor has slid across the floor. It's important that you remove this prior to testing using that sensor. Once the sensor's surface appears uniform, then it is ready for use. First, attach fresh sandpaper to the sensor reconditioning tool. Next, insert the sensor into the rotator, being careful to properly orient the sensor as noted on the diagram on the side of the tool. Place the rotator into the tool. Use your index finger on the corner of the sensor to hold it down until it is in the drum of the tool. Hold the handle of the insert of the reconditioning tool in one hand and grab the reconditioning tool in the other, turning it and beginning the reconditioning process. Recondition the sensor, periodically removing it to review the rubber surface. Brush both the sandpaper and the sensor with a chip brush or stiff paintbrush to remove the excess material. Complete the necessary turns to eliminate the wear pattern or flat spot in the sensor. The sensor should be smooth with no grooves and uniform. If smooth and uniform, continue to the next step. If not, remove the sensor and brush off the sandpaper and sensor with the dry paintbrush. Place the sensor back into the tool. Complete the necessary turns to eliminate the grooves or pattern as necessary and achieve a smooth surface. Once the sensor is smooth and uniform, remove the sensor from the tool. Brush the debris off of the sandpaper and the sensor with the brush. Place the sensor back in the tool and complete 10 more rotations only. Then pull the sensor out of the tool for the final time and wipe it off with a paper towel or a roll of paper towels. Now it is ready for use. Using SAND as an acronym, one can easily recall the process. S, A, and D. First, S for sand. Place a new piece of sandpaper in the reconditioning tool and brush it off with a chip brush or stiff paintbrush. Sand the sensor using a fresh piece of sandpaper for each location or set of 3 samples. Then, A for assess. Assess the condition of the sensor. Confirm that the surface is consistent and all gouges and scrapes have been removed. If required, sand again, brushing the sensor in sandpaper to remove dust. Then, N for now do 10. Brush off the sandpaper and sensor with a chip brush or stiff paintbrush and resand the sensor, rotating 10 times. Now do 10. And finally, D for do the test. Wipe off the sensor with a paper towel or roll of paper towels, and you're ready to test. Remember to replace the sandpaper for each new location using the sandpaper for each of 3 samples within the location and discarding it after. Now that you've reconditioned your sensor, it's time to validate that it is working properly. You do this using a verification tile, which is provided with the bot. And this is achieved by performing 2 tests on the provided validation tile. Each tile is provided with a designated value and precision contained on a label on the back of the tile. To validate the sensor, we will need the sensor we just reconditioned, 0.05% sodium lauryl sulfate solution created per the ANSI A326.3 standard, distilled water, Hilliard Renovator 120 or equivalent diluted per manufacturer's instructions with distilled water, typically at a concentration of about 1 in 10, a soft bristle brush, stiff bristle brush and/or scrubbing pad, and a cloth or paper towel that does not leave lint residue after use. Now, the goal here is to make sure that you've gotten a value that's within that range as designated on the back of the verification tile. This process should be performed on a flat and hard level surface. Tip the bot onto its side or back panel and fully insert the resurfaced sensor into the corresponding space on the bottom of the bot. Clean the validation tile prior to testing with the diluted Renovator 120 manufactured by Hilliard, using the scrubbing pad to remove any dust, debris, and contaminants that have collected on the surface. Rinse thoroughly with distilled water to remove all of the detergent. Allow the tile to air dry or dry with a hairdryer, cloth, or paper towel that does not leave residue. Wet the path for the sensor to follow with 0.05% SLS solution. The path should be about 1.5 inches wide and at least 10 inches long. Return the bot to the starting position with its wheels down and center the bot over the validation tile with its back edge lined up with the edge of the validation tile. The SLS path should fall right in the center of the bot. To verify the sensor, you're going to run 2 single measurements. Here is where we would indicate the location and area number if we were performing multiple tests. Since these single tests are simply to verify the sensor and are not part of the test, we'll set them to 0. Since we're following the A326.3 protocol for these tutorials, we're going to set the distance to 10 inches for the verification test. Make one dynamic measurement on the tile. Then turn the bot 180 degrees and make a second measurement in the opposite direction. If the average of your 2 single runs are within the range indicated on the back of the validation tile, the sensor passes the test and you can proceed with testing. If the value falls outside of the range, repeat the reconditioning, resurfacing process and clean the validation tile as necessary. If after multiple attempts to get the verification values to be within the desired range, you're unable to get those numbers, you can consider using a new sensor, and you should also thoroughly clean your tile. If after that you're still having issues, contact the manufacturer about replacing the tile. It's important to consider that after you're done doing the sensor verification, you need to repeat the resurfacing process before you perform your first test.